Hello everyone, my name is Satyakam Pratap Singh. This is the second tutorial session of the network analysis and whose instructor Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur, and I am Satyakam Pratap Singh. I am PMRF Research Scholar at Grid Integration Laboratory IIT Bombay. So we will go through the few of the problems related to network analysis. We will make sure to solve the numerical of the assignment 2 as well as assignment 1, and also if you wanted me to go to the further questions related to assignment 3, let me know. Okay, so this is the first question I'm putting forward. Is related to few of the problems which were remaining from the last tutorial session. So if you can solve it, try to solve it. Let me know if you're having any doubt. Okay. Okay, let me give the solution for this question, and I hope you are trying this question by yourself. So if you see in this question, there are different resistances which are connected in parallel in the series fashion. So this is a kind of question related to the series and parallel combination. So in the last class, what I have told, if two resistances which are connected in series, so it can directly added to the single equivalent R equivalent. So this is actually R equivalent will be equal to R1 plus R2. That is same thing which I have told in the last class. Okay. And similarly, if you see in the parallel fashions also, if it is a connected R1 and R2, so this equivalent can be converted into the R equivalent, that is R equivalent, and here the R equivalent will, okay. Just these two concepts which I have asked you to remember during the last classes, and also one methodology how to take know that whether the two resistances are connected in series or two connected in the parallel. Okay, so if you see the here this first one, that is a series connected system. If you see the series connected system here, the this is the one node of resistance R1, and this is another node. That is A, this is B, and this is the another node of R2, that is C. So if you see that the R1 node of the R1, that is A and B, and the node of R2 is the B and C. So the common node is actually the B. So in series connected system, both the resistances, both R have single node in common. Single node in common. Got my point? And if you see the parallel connected system, this is a parallel connected system. So if you see, suppose I am considering this is a node A, this is node B. So this node A is actually appearing this in between this R1 and R2 node, and that is similar node. Okay, they are the same potential, and this node also connected to the B. So these are the same potentials. Okay, so if you see that the both nodes of R1 and R2 are connected. Okay, so this means that in the series connected system, how to differentiate between the series and parallel combinatorial system, how to judge. So in the series connected system, the both no, single node will be common. So let me erase this. Okay, so let me both means single node will be common. Single node will be common, and this in this the both nodes will be common. Both nodes will be common. Okay. Let me erase this and try to solve this question basically. Okay. Okay. So let me solve this question. So if you see that this is all the resistances are actually uh, same. If you see from the figure itself, all resistances are given as this R. All resistances are equal to 1 ohm. So R is equal to actually 1 ohm. All resistances actually. So here the thing you have to see that that in this part, this node, if you see this part, if I can draw here, this part, this is actually similar to this. This one resistance is connected, and then two parallel resistances are connected. Now this is connected to the one common node. Okay. So what I have told from the definition itself that how to judge the series and parallel connection. Single node will be common, then it's a series, and both nodes are common. So if you see this R and this R, because both are equal, so this R is coming in parallel. The both nodes are common. So the equivalent will be come out to be R multiplied by R divided by 2R. It will be equal to R by 2. Okay. So here the R is actually the 1 ohm. So it will become 1 by 2 is equal to zero point 0.5 ohm. So R equivalent. Okay. Got my point? So the R equivalent of these two circuits. Okay. And similarly, if you see this R, it having the one node common. So this two combination, the whole combination will come out to be R plus 0.5 R, it will become 1.5 R. Okay, this whole combination. And if you see that this whole structure, this and this whole structure is actually a similar equivalent can be transferred into the two parts. One resistance, this resistance come here, and then the two parallel resistances of 1.5 R and 1.5 R. Getting my point? So R is actually 1 ohm, so I'm just neglecting it that R considered as a 1. So this 1.5, 1.5 will parallel and become 2. 1.5 cross 1.5 divided by 3, it will become 2. It will come out to be 0.75. So, so overall R equivalent will become R plus 0.75 R. It will be equal to 1.75 R. Okay. So if you see that same structure is replicated in the downstairs as well. So these two resistances will come in the parallel 1.75 multiplied by 1.75 and divided by summing up means say 5, 5, 10, 1, 7, 15, 2 and 2.5 means it will come out to be uh, uh, 0.8 uh, and then 7, then 5, 0.785 R. That is actually R is equal to 1, so 0.875 ohm. Similarly, if you see that what could be the total R equivalent, so the 1 plus 0.875 is equal to 1.875 ohms. Okay, so what could be the value of R? I is equal to V means 3 volt divided by 1.875. Okay, try to solve and give me the solution for this. So it will come out to be 8 by 5. Okay, 8 by 5 ampere. So here from the question itself, it is saying that the value of I is A by 5. A by 5, it means that A will come out to be 8. Okay, so the A is the correct answer for this question. Let's jump to the second part of this question. This is a simple question. I'm giving you a few minutes to solve this. Just read the question, you will get an idea how this ideal and the practical current source and voltage source is being represented. Okay, just let me know if you have any doubt. Okay, let me give the solution for this question. But a question asking that a practical current source is usually represented by. So if you see that though two types of voltage sources has been considered. So sources are basically divided into a kind of voltage source or a kind of current source. Okay. So in voltage source also there is a two category, that ideal voltage source and the practical voltage source. And the same with this current source also, this ideal current source and the practical current source. Okay. So there are two definitions, means things are there. Okay, you should know that okay, there are voltage sources and current sources, and which are also having the two practical things, that ideally how it is represented and also practically how it is represented. If you see the ideally how it is represented as, this is some voltage source, AC or DC if you see. So this is actually the ideal. There is no resistance here in series. So R is actually series resistance is equal to 0, only the Vs term will be given. So, but if you see the practically, it is actually this Vs and this is Rs. So here Rs is not does not equal to 0. So it is a kind of practical source which is having a series resistance with respect to the source. Okay. If you see the current source which is ideally represented, this is a current source, and here it could be a practical current resistance which is parallel with respect to the current source, but here this is not thing. So the practical that if you see the RP which is equal to infinite, because it's a open circuit system. But if you go with the practical current, this is the RP. Okay, okay. So this is the IS. This is the IS. So this is the source current and RP is infinite. RP is this value. Okay. So these are the values of the current sources. So let me go through the options. What is written that a practical current source is represented by a resistance in series with the ideal current source. But I'm saying this part. Okay. So it is not in series. So this is the correct incorrect option. So B option is resistance is parallel with the ideal current source. That is actually true because you can see that a parallel resistance is there in the parallel, and the C option is correct, incorrect, and the D is also. So B option is actually correct for this question. Okay, let us go for the next part. This is a question related to the ideal and non-ideal loads, which you will see in the loading is there, which is represented that linear loads are there, and the second is the non-linear loads. So this question is related to that, how to tackle this non-linear loads kind of situations. Okay, just let me know if you have any doubt with respect to this and try to solve this question. I hope you have got the solution for this question. Let me explain the solution for this question. So what is telling in the question that a 10-volt battery with the internal resistance of 1 ohm is connected across a nonlinear load whose VI characteristics are given as 7I is equal to V squared by 2V. So it means that one battery is there. It is connected with the one internal resistance of 1 ohm, and also there is a one nonlinear load. So this is a, let's just consider that this is a nonlinear load. This is a nonlinear load. Okay, and this is the 10-volt battery. Okay, so it means that suppose this is the voltage appearing across the V, across the nonlinear load, which is represented by the equation that 7I is equal to V square plus 2V. So it means that this nonlinear existing nonlinear load is actually a function of V and the I. Okay, so here the I is equal to function of V, means both are dependent. Okay, so easy way to solve this question that because you have the one equation, you need the another equation. You need the another equation to solve this kind of problem. Okay, because you have two variables. For solving that two variable system, you need the two equations. Okay, so one equation you already have. Second equation is such that if you see that this 10V, 1 ohm and the V. Okay, so the V will be equal to 10 minus I. Suppose the I current is going into this load. So 10 minus I times of R is equal to 1. That is 10 minus I. Okay. So this is the second equation which we have got. There is simple way because if you see apply the KVL. So consider this as a positive, this is negative, this is positive, negative, positive, negative. Okay. So it means that minus 10 plus 1 plus V is equal to 0. So it means that I, sorry. So the V is equal to 10 minus I. Equations for getting the answer. If you see, let's put the I part here. So it is 7, I is equal to 10 minus V is equal to V square plus 2V. If you solve it, you will get the equation like this, V square, 2V here, minus 10, 10 minus I, sorry. So this is the 10 minus I. So it will come out to V square, 10, 10 minus V. So this is the V only. The V square 2V, and here the minus 7V is there, V square plus 9V minus 70 is equal to 0. Okay, use the your calculator and try to get me the answer. What is the correct solution for this? Let me also solve for you. Fifth, uh, it is 1 9 minus 70. Okay, it is coming two values, that is a 5, and the second is actually equal to minus 14. So plus value we will consider because we have considered the V as a positive. So V is actually the 5 volt. And so if you consider the what is the current because we wanted to know the current which is delivered by the battery. So current will flow like this. Okay. So the current will be equal to I is equal to 10 minus V. 10 minus V means 10 minus 5 is equal to 5 amps. So the 5 amps is the correct answer for this question. Okay. So if it is given that there are non-linear load and you are having one equation is given, so you need the another equation by seeing the what is the circuit topology is there. Okay. So let's move to the next question, and this is the next question over you. You have to find out what is the current which is across the 2 kilo ohm resistor. Okay. Take your time and try to solve. Okay, let me give the solution for this question. What is question is asking that what is the current across the 2 kilo ohm resistor? So it is asking that what is the current across this. So if you see that these resistances are 1 kilo ohm, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm. Have you read about the concept of the Wheatstone bridge? Wheatstone bridge. There, suppose this is R1, this is R2, this is R3, this is R4. So if R1 by R2 is equal to R3 by R4, so in this case, there will be no current. The current will be zero in the in between resistance. Suppose this is the in between node, then so the I in between the CD will be equal to zero. That is in between nodes of C and D. Okay, so the voltage equal to same value, the current is equal to, if the voltage zero, the similarly the current will be also equal to zero. Okay, so here also if you see the 1 kilo ohm, 1 kilo ohm, 1 kilo ohm, so this equation, this criteria is actually applicable here also. So in this case, the current is voltage will be equal to zero. Similarly, the current will be also equal to zero. Okay, easy to solve. So let me give the another question for you. So this is a question related to nonlinear circuit only. So I've given the one form of question for the nonlinear circuit. Try to solve this problem. Okay, let me give the solution for this question. What is saying that as shown in the figure, 1 ohm resistor is connected across the source that has the load line. Load line means this is actually the IV characteristics. So this is the I, this is the V. So if you see that V plus I is equal to 100, similarly the V by 100 plus I by 100 is equal to 1. So the it is cutting points are 100 comma 0, and this is the point that 0 comma 100. So this is a load line. So this is important for the electronic circuit when you study the op amps and all, where the load lines comes into important features. Okay. So this is the IV characteristic of this load which is connected. So the one equation is given. So equation one we already have. V plus I is equal to 100. And what I have told in the non-linear equations, if you see the two variables, okay, you need the two equations, okay. One equation you already have. For the second equation, the V is equal to, if you see this circuit, this is the 1 ohm which is connected, this is 1 ohm. So voltage which appear across the 1 ohm is equal to I times of 1 ohm. This is I. So this V plus V is equal to 100. This implies that V is equal to 50. Similarly, the I is also equal to 50. So this is the answer, is the correct answer is the 50 amps. Okay. This simple logic question. So let's go to the another part. Okay. This simple question related to which of the elements are actually the memory-less element, inductor, resistor, or the capacitor. Take your time and let me know the solution. Okay, let me give the solution for this question. It was asking that which of the following is a memory less element. So in this question, if you see the resistor is correct solution. Why I'm saying that? If you see the inductor equation, that is a voltage. Voltage equation is voltage I L d I by dt. Okay. If you're finding the I value, it will come out to be 1 by L Vt dt is equal to minus infinity to t. Okay. So the minus infinity is coming here to some t. Suppose this is the t. So for this, you have to know the what is the value of current this I dt. Okay. Similarly, when you see the capacitor equation, I is equal to C dV by dt, voltage will come out to be 1 by C IT dt. Okay. So if you see that I is equal to C dV by dt, voltage 1 by C IT dt. And similarly here also I is equal to this. So this is actually the VT dt. Okay. So same equation for this. Suppose this is the IT dt, ITT. So you have to know the what is the previous value. So minus infinity to t for the finding out this voltage. Okay. So this is the way to find out which of the elements are actually memory element and which are the memory less element. Okay. Let's moving forward. Move forward for the next question. Okay. In this question, you have to find out what is the energy being consumed in the this circuit. If the current equation and the current curve is given. Let me know the solution. Okay. Okay, let me give the solution for this problem. What is question asking that okay, if the waveform of the current is given, suppose this is the IT dt, what is the value of energy? Energy being absorbed in the by the inductor, energy being absorbed by the inductor. Okay, so here the inductor is not a ideal inductor, it is a practical inductor. What do you mean by practical inductor? Inductor is having some internal resistance as well. This is L, this is R. So the what is the energy being absorbed? It will be equal to energy absorbed by the L, energy absorbed by the R. Okay. So what about the energy absorbed by the L is equal to half L I square. I at that particular time, what is the value of current of square? Okay. It come out to be half. L is given as 2. IT. IT, if you see that it is asking at the first 4 seconds. So at this point, this value, this is x is equal to 4, y is equal to 6. So I is equal to 6. So 6 of square, it will come out to be 36 of joule. What about the ER? There is no direct way to find out this here. Here, if you see that energy is equal to PT dt. PT dt is the minus infinity to t and PT dt. Okay. So what about the P? P is equal to I square R. I square R. R is given 1 ohm. So it will become I square TT. Okay. So for the first 4 seconds, before 0, it is 0, 0 amps. So what about the value of current? I is equal to, if you see this equation, I is equal to 3t time in between 0 to 2 seconds. What about the greater than 2? Greater than 2, it is equal to till 4 constant 6 amps. What my point? So ER is equal to square dt plus 2 to 4 6 of square dt. It will come out to be 339 t cube by 3, putting the value of 0 to 2, 36, and multiplying by 2. It will come out to be 3, you can cancel it out. 3, 2 to 4 to 8 plus 72. It will come out to be 8 3 24 plus 72. It is coming 96 joule. So if you see that, what is the overall energy? ER is coming out to be 96. EL came 36. The total, if you find out, it will come out to be 132 joule. This is the correct answer. Okay. So here the two things you have to make sure that whether it is a practical inductor or the ideal inductor. If it is a practical inductor, you have to consider the resistor energy absorbed also and the energy absorbed across the L. For finding the energy absorbed across the L, it is simply half Li square I of that particular time instance. And for the finding the value of ER is equal to PT dt. Power is equation I square R. R is given 1 ohm dt at a minus infinity to t. And if you see that t less than 0, it is 0. So we are considering the 0 to t I square. I equation in between 0 to 2 is 3t, 3t of square plus in between the 2 to 4, it is 6 of square dt. So it will come out to be 9 t cube by 3, 3 and then plus 36 multiplied by 2. It is coming out 72 plus 3 multiplied by 8. It is 24 plus 72, 6 and then 9, 96 joule. So summing up the overall energy consumed or absorbed, it's a 96 plus 36, it will come out to 132 joule. Okay. I hope you have got the solution for this question. Let's move to the next part. Okay. Let's try to solve this question. Okay, let me give the solution for this question. What is asking that in the circuit shown in the figure below, it is desired to have the constant direct current. I mean, it is was asking that IT is equal to constant. Okay, so through the ideal inductor L, so this IT which is given here, it should come to have the constant value. So it is asking that what is nature of voltage source VT. Okay. So let's take the few of the values. Suppose voltage across the inductor will come out to be voltage L di by dt. So the I will be coming out to be 1 by L minus infinity to T Vt dt. Okay. So in this question, if you see that voltage L di by dt and I is this. So what is asking that if IT is a constant or not. Okay. Let me take the value. Suppose the for the first option A. So this is a constant voltage, means that the V is equal to take let's take one value A volt. So for this the what is value of I? 1 by L. A is constant. A is constant means A and then A this is time T. Okay. So this will come out to be 80 by L. So this is nowhere it is coming constant. Okay, it is a function of time. So let's take the second option. Second option B. It was saying that linearly increasing voltage. It means that so suppose let's take that voltage equal to A times of T. So here what is the value of I will come? 1 by L minus infinity to T AT dt. It will come out to be AT square by 2. Let's need not take the this is a kind of um, unbounded system, unbounded integration, not bounded. Okay, it will come out to L A T square by 2 plus C 1 by L. Okay, so here it is. This is also not coming constant. It is a function of T square. Let's take the third option. Third option C. Here what is saying that a voltage function delta T. Okay, so if you see the I 1 by L minus infinity to T or some non-bounded system also delta T dt. So if you see the delta T, this area, this is actually equal to 1. Okay. So this fourth option that is similar that if the exponential, the integration will also come out to be exponential. So the fourth option is nowhere coming. So first option is neglected. So second is also neglected. Third is correct option. Okay. So in case of the impulse function, you will get the constant current. Okay. Let's move to the next part. Try to solve this problem. Okay, let me give the solution for this question. What is asking in this? Ki voltage current waveforms are given. So this is the current waveform which is given, and this is the voltage waveform. Okay. So in this question, what is asking? What is the circuit element and what is its value? So if you see in the first problem, IT is given as some of the equation which is given. Suppose let to find out the what is the equation in between 0 to 3. Similarly with the 0 to 3, IT is equal to come out to be 1 t time in between 0 to 3, and similarly IT is equal to 3 amps if greater than 3. Getting my point? Same, same if you see the voltage equation, VT come out to be 3 in between 0 to 3, and VT is equal to 0 t greater than 3. Okay, so let's assume that it is a resistor. For the resistor, IT is equal to VT by R. Getting my point? But this two equation, if you see in between 0 to 3, in between t is equal to 0 to t is equal to 0 to 3, it is nowhere coming IT is equal to VT by R. It is not equal to VT by R. So this is not a resistor. So let's assume that it's an inductor. So in between t is equal to 0 to 3, so it is coming that if you see that IT is coming in between 0 to 3 is t. Similarly, the voltage 3. You can assume that voltage is equal to L di by dt. If you differentiate this t, it will come out to be L. Okay, it is coming constant. Similarly, in between greater than 3 also, if you see the IT is coming out to be 3. The voltage, what is the value of voltage? It is coming 0. So these both equation that IT and VT, this VT is coming out to be L. But VT, what is the value given? VT is equal to 3, which is equal to L. So this is a circuit element is inductor, and its value is 3 Henry. Got my point? Try to find out which equation is actually replicating the behavior of this element, and then they find out the value by comparing the voltage, the compare or the currents. Okay. Let's move to the next equation, next question. So this is a question. You have to find out the what is the value of time constant. Take your time. I will explain what is the correct solution for this question. Well, let me explain this question for you guys. Uh, if you're finding out the what is the value of time constant, so if it is a transient circuit is given and you have asked to find out what is the value of time constant. In this situation, try to find it out when the questions means after the t is equal to 0 plus second. Okay, after the switch is being closed, after the switch is being closed, switch is being closed. So in this circuit, if you see, if the switch will close at t is equal to 0 plus, and also two things. If the source, voltage source is there, short circuited. If there is a current source is there, open circuit is. So in this circuit, if you see the voltage source is 10 volt. So let's short circuit it. And this is the resistor R. This is the resistor 2R. And this is the C. Okay. So this resistor R, suppose this is the one node of this, one node of this. So this node is connected to the 2R node. So this node, if you see, this is the A, this is the node B. So these two nodes are common for the R also, 2R also. Okay. And this is the C. So the equivalent of these two, because they are in the parallel, it will come out to be R equivalent as R multiplied by 2R divided by 3R. R plus 2R, that will come out to be 2 by 3R. Okay, so this is 2 by 3R and this is the value of C. So across C, what is the value of RTH? And RTH is coming as 2 by 3R and this is the C. So it will value will be equal to time is equal to zero point 0.7 and this 3.336 is come out to be means 0.67 RC. So no option is correct actually. So it is R tau is equal to RTSC, which is coming out to be 0.67 RC. So this is the correct solution for this question. So let me move to the next part. So in this question, you have to find out what is the value of IT under the steady state condition. A steady state matlab t is tends to infinity. During that time frame, you have to find out the what is the value of IT. Okay, take your time to solve. So let me explain this question, and after that I will give the few time to solve the other parts as well. So suppose one circuit that under the transient condition L and C components are there. So individually asking the L and C elements are there. Elements are there. So the value of current, always remember that I at the particular time t will be equal to I infinity e to the power minus t by tau. Tau you have how you are going to find out? RTSC by the same method which I have explained in the previous class. So what and also the voltage across the C, it will come out to be V infinity plus V0 minus V infinity e to the power minus t by tau. And same here also the tau is equal to RTSC. So if you see in this question under the steady state, so there is a one methodology that is superposition theorem. You will learn it in the future scope of this class. In this, if there are two sources, so take one sources at a time and try to solve. So here the two sources are there. One is the DC, one is the AC. Let's take the DC part first. DC part. So always remember that under the steady state condition, the inductor L will be short circuited and the capacitor will be open circuit. How this will become as? So here the L is also there, C is also there. If this V will become open circuited, no current will flow. And so under DC condition or under the DC voltage source, the I is equal to 0. Okay. So let's take the AC component. Let's take the AC component. What will be the value of I here? What is the value of I? I will become equal to 10 sine t. What is the voltage divided by the impedance? Impedance what is coming? R plus j omega L. Omega is here 1 because this is sine omega t standard term, and omega is here 1. The same omega will be reflected here also. So it will become j2 and this will become minus j. Okay. 1 plus j2 minus j. It will become 10 sine t divided by 1 plus j. After trying to solve it, it will become 10 by root 2 sine t minus 45 degree. Why? Because 1 plus j will come, its magnitude will be root 2 angle plus 45 degree. It will go in the numerator, will become minus 45 degree. So the total I will become as IDC plus IAC. IDC is 0. So IAC will become root 2 means 10 root 2 10 by root 2 actually. So it will become 7.07 sine t minus 45 degree. Got my point? So the correct answer is D. So the same thing you have to apply that. Always remember this equation, IT equation, VCT equation, and also this part that when the DC source is there under steady state condition, inductor will be short circuited and capacitor will be open circuited. Let's move to the next part. So this is the next question I have kept you for, and try to solve this question, and after that I will give the solution for this. Okay, let me solve this question for you guys. If you see in this question, what you're asking that a series RC circuit is shown in the figure. The voltage across C start increasing when the DC source is switched on. Okay, what is saying that T is equal to 0 plus this switch is being closed and this voltage across C is go on increasing. VC increases. So the rate of increase of voltage at instant just after switch is closed means it is asking dVC by dt at t is equal to 0 plus. So in the previous question what I have told VCT is equal to V infinity plus V0 minus V infinity e to the power minus t by tau. So this is a kind of generalized equation. Okay, this is a generalized equation. So if you see the V infinity is and when the switch is closed and the circuit is under steady state, I have told V infinity means inductor will be short circuited and the capacitor will be open circuited. In this case, the V infinity will become VC infinity basically. VC0, VC infinity. VC infinity will become so switch is closed, so circuit will look like this. Circuit is open circuited, no current will be passing through here resistor, so the voltage is 0 here, and this is the -1, +1, and this is the sorted. So because the switch is closed, and this is so VC infinity will become this. Suppose this is a positive, this is negative. Positive coming here, positive here. So VC infinity will become 1 volt. Okay, got it? And similarly, VC0, if you see when the switch is open. So the circuit was like this. The capacitor is like this, resistor is like this, switch is open, and this was the 1 volt. So if it is a open, no voltage will be appear here, no voltage will appear here. So all voltage is appearing across the switch only. So this will come out to be -1 volt. But in this situation, if you suppose this is positive, this is negative, so it will become V switch is equal to -1, and the voltage across the capacitor is 0. VC0 is equal to 0. So what is the exact value of VCT? It will become 1 plus 0 minus 1 e to the power minus t by tau. Okay. So it will come out to be 1 minus e to the power minus t by tau. Got it? So for finding the dVCT by dt, differentiate it, it will become -1 minus 1 by tau at t is equal to 0 plus. Okay. So if you put the value of 0 here, e to the power minus t by, it will become 1. So what is the value of it? Tau. So tau is equal to 1 upon RTSC. So if you find out the RTH across the C, it will come out to be R only. So it will become 1 upon RC. Got it? So moving to the next question. So in this question, if you see the VI characteristic is given as shown from the terminal AB. This is the terminal AB. It is given VI characteristic of the as the figure 1. This is the VI characteristic actually. If the inductances of the value of 6 milliohm is connected across the in this is the one inductor is connected of 6 millihenry, and the time constant of the system will be in microsecond will be okay. So what I have told the time constant, you see this is the equation of the current and the voltage. So I is equal to equation, if you write the equation it will become I divided by 4 milliampere plus voltage divided by 8 is equal to 1. Try to find out the equation, what will become 4000 I plus V by 8 is equal to 1. So here the 2 multiply, it will become 2000 I plus V is equal to 8. Okay. So if you see that for finding out the what is the value of resistor and all, so the resistance is actually equal to the dV by dt, dV by di. So let's find out the minus of something because the equation is actually the different. So differentiate it will come out to be 2000 I with respect to I we are dividing dV by di is equal to 8. So 8, sorry, it is 0. So dV by di will come out to be RC, sorry, tau will become L by R, L by RTH. So the R will come out to dV by dt is it will come out to be minus 2000. Got it? So when you multiply it L because the dv by dt, so it will be equal to minus r naught because the negative slope is there. Okay, so it will come out to be L is 6 millihenry. It will be 6 minus 3 divided by R, that is 2000. V is equal to, with respect to I, are differentiating. V is equal to R naught. d by dt is equal to minus R naught. It is 2000 minus 2000. And this is the R, L by R, L by R it is given. So it will come out to be 6 by 2000 microsecond. Okay, this is tau. So time constant will come out to be in 6 by 2000, 10 to the power 3, 10 to the power 3 in the microseconds. So it will become as 6, 3, 2000, 6 by 2, 6 by 2. So it will come out to be 3 microsecond. Got it? So this is the simple way to solve this kind of equation. Just try to find out what is the value of this equation. Another part of the question, that is the different question, that what is saying that a ideal voltage source will charge a ideal capacitor in what amount of time. If you see in this question, what is asking, if there is a voltage source, if I have applied a voltage source, ideal voltage source basically, and one capacitor I have connected, this is an ideal capacitor. These two things you have to remember, the ideal voltage source and the ideal capacitor, because if you see the ideal voltage source, there is a Rs, which is series resistance, is equal to 0. And similarly with the ideal capacitor, there will be no resistor in between. So Rs of this C is also equal to 0. Okay, these two things are there. So this is a capacitor C, this is a voltage V. Okay, in what amount of time it will charge this capacitor? So if you see that this VCT is equal to what I have told, V infinity plus V0. Okay, you have to find out what is the value of T to charge this capacitor. Okay, if it is a fully charged, let's assume that V came out to be, this capacitor came into the steady state when it is fully charged under the steady state condition. Okay, in this condition, V infinity will become voltage V only. Okay, so the VCT is equal to V plus, it will, how to charge, so V0 is equal to V minus V0. V0 is actually, let's assume that 0 minus V e to the power minus t by tau is equal to V 1 minus e to the power t by tau. Got it? What I'm saying that this V will become exactly equal to V in what amount of time? Let's assume that, let's subtract it. 1 will become is equal to minus V t by tau. Just take the ln. Ln is equal to 1 minus t by tau. So ln1 will be equal to 0, t is equal to 0. It means that it will charge the capacitor in the instant of the time, because there is a no voltage drop or no resistor in between. Okay, so it will charge the capacitor, this ideal capacitor, in instantaneously. Okay, so this is t is equal to 0 at a time. Okay, so moving to the next question, if you see this question, what is asking that there is a one rectangular voltage wave is given. This is a rectangular. Let's assume that this is a rectangular voltage which is applied across. This is with the voltage magnitude V and time duration T. It is applied across a combination of R and C. This is the R and this is the C. So this is rectangular pulse. Rectangular pulse is applied across this RC circuit. This is the RC circuit. Okay. What is asking the question? What is the VC max? What is the maximum voltage will appear across the capacitor C? So in this question, if you see what I have told in the previous question, that VCT is equal to a standard equation V infinity plus V0 minus V infinity e to the power minus t by tau. Okay. If you see this question, this is a voltage which I have applied, that is a pulse voltage. Let's assume that there is a one switch is there. When you are owning switch on every interval of t by 2. So when you switch on this voltage, it will appear across the R and C. It will constant as V. So when you switch off this switch, second, this is a t by 2 and this is t, will appear exactly similar to the a switch which is connected across the R and C. Okay. When the switch is on, the voltage V will appear. When the switch is off, the voltage will become zero. Okay. So what the value of voltage at a V is equal to zero. Zero means it is a open circuited. Open circuited means there is no voltage drop across the C because it's a open circuited. I will be equal to zero. What about the voltage across the V infinity? V infinity means capacitor will be open circuit. I'm assuming that it is under steady state condition. It will appear across the VC. That is a V. Plus V0 is 0 minus V e to the power minus t by tau. Tau, what is will equal to? Tau is equal to RTHC is equal to RC. So actual value of VCT will become V1 minus e to the power minus t by tau. Okay. What is asking the question? What is the maximum value which develop across this capacitor? If you see in this question, it will develop across the capacitor when it is appearing. Means if you see that, let's take the problem here. It is appearing across at the terminal T also at the terminal in between the T0 to T by 2. Why? Because in between 0 to T by 2, the voltage is equal to constant which is equal to V. Okay. In between T by 2 to T, the voltage which is appearing across the capacitor is 0. It means that it is a kind of circuit when it is started charging and then it discharge. Then after that it charge, then discharge. Kind of equation is there. And discharging through R. Okay. So what is the maximum value it will appear? It will appear across the at the value of T. So the VC appear across the V1 minus e to the power minus capital T by tau. And the tau is equal to RC. Got my point? So this behavior of the rectangular plugs is similar to the switching operation, and this switching operation, the maximum voltage appearing in between the time frame 0 to t by 2. So the maximum value of the capacitor will be V1 minus e to the power minus capital T by tau. Tau is equal to RC. Got my point? So let's move to the next question. In next question, what is telling that there is a voltage waveform. Voltage waveform is given as Vt is equal to 12t square. And this is appearing across an inductor. This is appearing across an inductor L is equal to 1 Henry at a time t is equal to greater than or equal to 0. With initial current through the inductor is 0. It means that IT is equal to 0 minus is equal to 0. Okay. So the current through the inductor for t is greater than 0 is. So the current L what is given 1 Henry di by dt is 12 to 24t. It will come out to be 24t. So the what is the value of current? It will come out to be 24t. Okay, but at a greater than 0. But with this less than 0, it is equal to it is equal to 0. Okay, so two equations you have to remember for the capacitor and the inductor. I is equal to C dV by dt. If you're finding the voltage, it will appear 1 by C it dt, and this is the integration minus infinity to t. Same with if you see the voltage across inductor, it will be L di by dt, and the it will be here it will be I is equal to 1 by L integration of minus infinity to t it dt. Got the point? So just differentiate it, it will become 24 by t, which is greater at a value of greater than 0. Let's move to the next question. In the next question, what is asking that the capacitor initially has a charge of 10 coulomb, that Q is equal to 10C, 10 coulomb. Current in the circuit at t is equal to 1 second after the switch S is closed will be. Okay. So here if you see the RC circuit is there and the one voltage is given. And it is asking that when the switch is closed, current T is equal to 1 after the switch is closed will be. Current in the circuit at T is equal to 1 second after the switch is closed. Okay. So initially switch was open, but at T is equal to 0, the switch is being closed. So in standard equation of VCT, capacitor is equal to V infinity V0 minus V infinity e to the power minus t by tau. Got my point? So initially Q is given as 10 coulomb. Q is equal to CV. C is given as 0.5 V. So the V0 minus V at a time of 0 minus, it will come out to be 10 by 0.5. It will become 5, 10, 20 volt. Okay. And the V infinity means when the circuit is at the state under the steady state, the capacitor will be open circuited. Open circuit means 100 volt will appear across this. Okay. So standard equation will become VCT is equal to 100 plus V0 minus is V0 is equal to 20 minus 100 e to the power minus t by tau. What is the value of tau? Tau is equal to RC. RC short circuit the voltage. If you short circuit it, it will become RTSC. RTH is given 2.5. It came out to be 1 second. T by 1. Okay. So standard equation will become 100 minus 80 e to the power minus t. Current I is equal to C dV by dt. Okay. C is given as zero point 0.5. Differentiate the value this voltage. It will become minus 80 minus 1 e to the power minus t at a 1 second. It will come like this. It will become 40 by e. 40 by e will come out to be 14 by 7. 14 by 7 amps. Let's take the calculator. 40 divided by e. 1 is equal to 14 by 7. 14.71 amps. So this is a standard procedure to solve any of the question related to switching circuit. Let's move to the next problem. Next problem, if you see in this question, it is asking that for the initial capacitor voltage 0, VC0 is equal to 0, switch is closed at t is equal to 0, and then the final steady state voltage appear across the capacitor is. So what I have told, under the steady state condition, steady state condition, steady state condition, capacitor will become open circuited and inductor will be the short circuited. Okay. So if you see in this question, if the capacitor under steady state will become open circuited, the circuit will look like this. This is 20 volt, this is 10 ohms, and this is the open circuited, and this is the value of 10 ohm. So the voltage which will appear, so current is equal to 20 divided by 20, it is 1 amps. So the voltage across this is the same voltage which appear across the 10 ohm. So the voltage will become 10 multiplied by 1 is equal to 10 volt. This is simple way to solve this kind of question. So this is the 10 ohms is the correct answer. So moving to the next question. In this question, what is asking that a circuit shown in the figure is in the steady state. Means circuit was initially at initially at initially at steady state. Initially, it is already at a steady state. Okay. At t is equal to 0, the current through the inductor is asking. Current is asking at t is equal to 0 plus. At the switch t is equal to 0 plus, it move from the steady state to non-steady state, transient behavior. Okay. So if the inductor was already at the steady state, this how it is become to behave like. So at a t is equal to 0 minus, the circuit was similarly like to, because it was in the steady state, so it will behave like this. Inductor was short circuited, so it was like this, 10 volt, 10 ohm. So it was the current which is flowing here. It was 10 by 10 is equal to 1 amps. Okay, always remember that inductor resists the sudden change in voltage, sudden change in current, sudden change in current, change in current. Similarly, capacitor, it also resists the sudden change in voltage. So if they are resisting the voltage, it means that I at a t is equal to 0 minus will be equal to I at a t is equal to 0 is also equal to the I is equal to t is equal to 0 plus. So I t is equal to 0 minus is actually 1 amps, which will be equal to I t is equal to 0 plus. So the current will come out to be 1 amps for this question. Okay, got it? So moving to the forward to the next problem, what is saying that what is the time constant of this circuit? Okay, so what I have told in the finding the time constant, just find the value of tau is equal to RTH and C across the C. Okay, if there is a sources, if it is a voltage source, short circuited. If it is a current source, open circuited. Okay, here the current source is there, open circuit. After the open circuit, you will get the circuit like this. Okay, this is the open circuit. What you have to do, if you see, this is the, you can find out the equivalent of C here, R equivalent from here. So this is R equivalent and this is C equivalent. This is 1 farad, 1 farad, 1 farad, and this is 3 ohms and 3 ohms. Let's find out the value of C equivalent. It will in the parallel, so it will just add up. It will become 2, and in series with this 2 multiplied by 1 divided by 3, it come out to be 2 by 3. So capacitor is equal to 2 by 3 of C. R equivalent will come out to be 6 ohms. What is the value of tau? Tau will be equal to 6 multiplied by 2 by 3. It will come out to be 4 seconds. Okay, tau, time constant. So C option is actually the correct. Okay, so moving to the next part of this session. So if you see in this question, what is asking that a series RL circuit is given. Series RL circuit. Series RL circuit is excited by the because this is the false. This is false. Okay, let's move to the next part. Let's see that if it is a correct part or not. Okay, this is the question. Okay, actually. So in this question, what is asking that a series RL circuit is given. Series RL circuit is given. It is excited at t is equal to 0. So it is excited at t is equal to 0. It means that switch is being closed at t is equal to 0 plus. Assume that 0 initial condition. It means that Ki L at t is equal to 0 is equal to 0 because it's open circuited. The value of I dit square, d square I by dt square at I at t is equal to 0 plus it is asking. So what is the correct standard equation of IL? IL is equal to I infinity plus I 0 minus I infinity e to the power minus t by tau. What is the value of tau here? Tau is equal to L by R. Okay. So what is the value of I infinity? I 0. I 0 is given 0. What is the value of I infinity? If you find out the I infinity, it means that key inductor will be short circuit. Phi LT will become, it will become V by R 1 minus e to the power minus t by tau. Let's find out the d square IL by dt. It will come out to be V by R minus 1 upon tau e to the power minus t by tau. It is equal to V by R tau e to the power minus t by tau. Let's differentiate again di by dt. D square ILT by dt square. it will come out to be VR by tau minus 1 by tau e to the power minus t by tau. Okay. What its value at t is equal to 0 plus, at similarly at t is equal to 0, it will become minus v by r tau square. So what is the value of tau? Tau value is equal to L by R. Let's put the value into the equation. It will become d square I by dt square will become minus v by r tau square. Tau square is L square by R square. R will get cancelled out. It will become minus VR divided by L square. So this is the correct answer. Correct answer is D option. So minus VR by L square. So this kind of question can be expected in the transient stability questions. So if you go from the first question is related to the R equivalent. R equivalent means what is the equivalent in the series or the parallel combinations. Second question related to the sources, that is the voltage source or the current source. Third problem was related to what is the value of the current or voltage when you have the non-linear loads. And fourth question was related to similarly the Wheatstone bridge. Fifth was related to the load line and similarly the non-linear behavior of the circuit. And this was the memory element. And other question related to what is the value of energy being stored across the inductor, capacitor, resistor, how to find that if it is a combination of both is given. Similarly, the other question related to that, which options are correct when you wanted to get the constant DC current across the inductor. Similarly, some of the related to elements, whether which elements are there, and this is related to how to find out the tau. Tau is the actually the time constant RTSC. Similarly, at a t is equal to 0 plus, this circuit will behave as similarly for finding out the RTSC. If the voltage source is there, you should short circuit, and if it is a current source, you have to open circuit it. Similarly, the behavior when the how to find out when the two sources are given in the steady state operation, which will be the most effective part. Similarly, the other question related transient behavior like VCT equation, ILT equation, and a particular instant of time, what is the value of voltage, rate of change of voltages, and elements, how to find out whether it is a exponentially increasing, instantaneously it will charge. Kind of different questions are being asked. So this is the overall structure of this today's tutorial session. I hope you have enjoyed and let me know if you have any doubt. Okay, let me end this session for today.